we have an important button there, that is the Create Alert. Create Alert basically trigger a mechanism inside event type itself that fully reconstruct the parent-child relationship and the events associated around this specific instance of MS Edge, for example. So we can create our own alerts. This is useful when we are investigating a particularly strange behavior, for example, and we want to understand the entire chain. So meanwhile I'm talking, ReaQta is doing all the correlation job for us. So instead of going there and doing this manually, so MS Edge has been executed by another instance of MS Edge with this PID. Who created this PID? So we should manually reconstruct it. We have an example of alerts. So I triggered the creation of this alert, and I'm now investigating the alerts details. I'm not going to spend too much time on these specific alerts because there are more interesting ones, but what I wanted to show you is the entire workflow, so what we can do and what an alert is. In the alert, you can see the affected endpoint, so you can consider it the victim endpoint, a reconstruction of what happened through the behavioral tree. So the elements that you see there are the processes involved into the attack. We had MS Edge, and as you remember, it was the child process of another MS Edge instance. This MS Edge instance has been spawned by widget.exe, so we can perform a complete investigation of what is going on. And by going at the end of the alerts details page, we have the collection of the events. So all the events involved in something that is anomalous, malicious, known to be malicious, suspect, as we want to call it, are collected within the alerts itself. So the alert is a collection, a correlation of events. I'm now going to show you a more interesting alert. This alert is useful because clarifies the behavioral approach and gives an idea of what happens in real life. As you can see, the name of this alert is behavioral anomaly. The behavioral anomaly that we observed there is wingword.exe, so the real wingword, the office that we daily use for data, for writing documents and so on, spawned an additional process, a child process called Tremi. And if you think about it, how is typically a malware, at least a document-based malware, triggered and delivered? By running an instance of WinWord, Excel, PowerPoint, wherever in the Office suite that generates an additional process. It can be the embedded malware itself. It can be a PowerShell script, a macro, a VBS macro. So we have an anomalous chain, a behavioral chain, WinWord spawning additional processes. And approaching the problem in this way relieves us from chasing every single document file, because we don't care if we are dealing with a macro document, a malicious macro, a DDI document, or even an exploit by some extent, because we don't care how the result is achieved. At the end, the scope is to execute a binary, to execute a process. So what happens there is that the detection is based exactly on this. It's based on the fact that WingWord is spawning an additional process. This automatically triggered the generation of the alert, the endpoint to start collecting even more events, because it's going in deep monitoring mode, so it's collecting even additional data when an alert is running. And similarly to what we saw in the previous example, we have a number of indicators to help the analyst, like for example the key events. We have some network connection, WiniNet, another layer of detection triggered the Destra itself. We have MITRE attack techniques. It was a macro document. We saw that it's a macro enabled. We have a macro enabled event. Executables were dropped on the system. System or running processes were altered by a cross-process operation, and we have mapped in memory some executable, so the indication of in-memory executable. On the other side, we have the indication provided by the analyst, so we know who is the analyst and the response of the analyst. After analyzing it, it has been marked as malicious. We have again, as before, the affected endpoint, and there the full behavioral tree. So from there we can understand who was the victim. We can see that the victim was the user Robert. What happened is that he simply clicked on a document. How we can understand this? Because the various circles that you see represent each one a process. The continuous line is a parent-child relationship. So we have Explorer that executed the WingWord. WingWord executed the TryMe, and so on. Then we have this dashed line. The dashed line represents an event relationship associated to TryMe.exe. We have a key event, so an event that is particularly important. Also, as you can see, compared to the other circles, we have two of them that have a blue circle. The blue circle represents the trigger process, means that those are the two responsible for triggering the anomaly. As an analyst, at this point, I have the possibility, by clicking on each one of those, to go in depth and see indeed the victim, the privilege level on which this instance was running, and from the command line we can also pinpoint the specific document that is considered caused the incident. Let's say it's this document located in the desktop folder. So we have an indication of the artifacts and where the artifact is located. We have a continuous line, so associated with TryMe, with the WingWord, we have TryMe.exe. And already from there you can notice something interesting. WingWord has a valid certificate and is signed. TryMe has no signature, so this is already something really suspicious. It's dropped into a temporary folder, so we know where the artifact is, we have the hash, and is not signed. Then we have TryMe.exe connected, and in the middle we have an hexagon, to Internet Explorer. When there is this indication of an hexagon, means that we don't have a parent-child relationship, but an event relationship. So TryMe.exe performed a cross-process operation, transferred the content of the malicious code from TryMe.exe to a legit instance of Internet Explorer itself. As you can see, it's Internet Explorer with a valid certificate from Microsoft. Internet Explorer started acting maliciously on the behalf of TryMe.exe. This is visible from this dashed line, in which you can see an executable dropped, so additional evidences and artifacts. An executable, an in-memory executable, keylogging. So as you can see, Internet Explorer started acting as a malware. Now, if you think about it, we just did a complete analysis of the malware, the root cause, simply by using the behavioral tree. And while I was talking, I reconstructed the storyline. Indeed, you can see that the first step is wingward. Then we have try me, then we have the cross-process operation, and so on till the final real malicious operations that are performed by a legit process that has been altered. So as an analyst, if you just run the list of the processes, you won't see you won't have been able to see anything strange, because you have a legit instance of Internet Explorer running. So this is a powerful way to understand what is going on, what is happening during an attack. In this case, it's important to highlight that we have been running this endpoint in detection mode, so without enabling any kind of protection, in order to be able to follow the entire behavior of the malware. In case the protection, that is another kind of policy, another type of policy, the protection indeed, the infection chain would have stopped at the first anomaly, so at level of tremi.exe. As an analyst, we have additional help, because by closing the alerts, by handling the alerts, we have the AI component, the cyber assistant, that is helping the analyst, learning from the analyst and helping the analyst. In this case, the cyber assistant detected it as malicious, is recommending us to handle this as malicious. The reason why is it found a nice similarity with previous alerts. So by learning from the previous alerts, it saw a similarity among previous events. The analyst, in all the cases, in all the past experiences, marked all the previous elements as alerts as malicious. Then we should not forget we are dealing with infrastructures. So compared to the past, when something happens on a machine, very likely is not limited to the specific machine. So it's important to have a complete, full overview, the infrastructure overview. And indeed, there we have an additional help and indication for the analyst. It is the infrastructure artifact, where those specific binaries has been found across the infrastructure. In this case, is a demo instance, so we have just one instance of tremi.exe for this machine only. Imagine a situation in which multiple users received the same binary. This gives you an idea of the extension of the surface that has been impacted by the attack. Additional indicators are the cloud analysis, so by leveraging external resources, and the MITRE representation. So inside the alert, we have a number of information presented in different ways, from the specific behavioral tree to the MITRE classification. Then we can go in the details, so following the logic as seen previously for the endpoint, we can go on the specifics of every event observed within this alert. So this alert is composed by 170 pages of events, so we can go even in details and see, for example, this file read, who performed it, and on which file. So we know that the file accessed is this JSON file, for example. Plus, of course, the typical filters that you find when dealing with long tables. So possibility to filter by specific events. To complete the view of what we can do with ReaQta when dealing with an alert, we have the remediation. Through the remediation, we can apply a number of steps to clean up the machine. So, for example, we can terminate this process. We can remove tremi.exe because it's malicious. This is an executable that has been dropped by the malware. So at the end, following the wizard, we can apply, in bulk, the steps that we believe are the remediation response. So deleting tremi.exe, killing the malicious instance of Internet Explorer, and removing the additional dropped binary. So in this way, we are able to handle an alert. Handling an alert means also dealing both with false positive or events that we want, alerts that we want to block, even if they are not classified as something malicious.